Hello, this section is about trigonometric integrals. In this section, we will learn how to use trigonometric identities to integrate a certain combination of trigonometric functions. That means before we start integrating, let's recall a few basic trigonometric identities. One of them is Pythagorean identity, of course, and we remember sine square x plus cosine square x equals to 1. I can take this equation and I can solve for sine square of x, which will give me an expression in terms of cosine. That means I can rewrite sine in terms of cosine, or respectively the same way, cosine in terms of sine. Of course, sine square and cosine square. Also, what I can do, I can play with my even exponents. Having sine to the power of 4, okay, that's even exponent, even power, I can rewrite as a sine square and again squared. And the sine square, of course, I can use Pythagorean identity. That's another way to rewrite sine function in terms of cosine. Because we will need this, we will need to know how to rewrite one function, one trigonometric function in terms of the other. Sine to the power of 10, let's say. 10 is also an even number, of course, even power. 2 times 5. That means still the square, sine square of x to the power of 5. And sine square is 1 minus cosine square of x to the power of 5. We also have double angle formulas. And this is the formula for sine of 2x, sine of the double angle. That means sine of 2x. We can't factor out, we can't touch that 2. That means, please remember, that's angle. We can't play algebraically with this. That means sine of 2x, it's equal to 2 times sine of x times cosine of x. Okay? And sine of x, cosine of x is x is a single angle. And I don't know if I will need this, but I did just divide by 2. Now, cosine of 2x looks like cosine square of the single x minus sine square of single x. Okay? Please note, looks a little bit similar to the Pythagorean identity, but it's different. Its cosine is first and it's subtraction. Okay? Now, the formula cosine of 2x, I can rewrite this formula just in terms of cosine or just in terms of sine of x. Because what I can do, I know from the Pythagorean identity that cosine square of x is 1 minus sine square of x, which this will give me 1 minus 1 sine square of x and minus another sine square of x minus 2 sine square of x. Or I can rewrite it just in terms of cosine, which means sine square of x is 1 minus cosine square of x, but the negative in front will change the sign, which this will give me negative 1, I can maybe put here, 1 cosine square of x, and negative will give me positive 2 cosine square of x. That means that's the red formula, and the green formula is exactly the same like the original one, but this one is in terms of sine, this one is in terms of cosine function. Okay, we also have half-angle formulas, which we can derive from the double angle formulas. Okay, that means what I took this one, the red one. Cosine of 2x is equal to 1 minus 2 sine square of x. Or cosine of 2x is equal to my green formula, 2 cosine square of x minus 1. And we can see this is nice way, because what I will do, I will solve this formula for sine square of x and the second for cosine square of x. That means subtracting 1 and dividing by negative 2, I'm getting this 1 minus cosine of 2x over 2. The same for this one, adding 1 to both sides and dividing by 2. I have 1 plus cosine of 2x over 2. Okay? And we call this half-angle formula, and we will need them. This one and this one. That's we can see double angle and half angle, important. And of course, always Pythagorean identity. This one is giving me the square, which is a product. Sine square of x means sine of x times another sine of x. I can rewrite without any product. I do have double angle, but that's not the problem if we will think in terms of integration. It's just the inner function, which the u substitution will take care of this. Okay, that we can see it's really helpful equation, really helpful expression for the cosine square of x or sine square of x. Okay, one more thing before we start integrating. I really want you to understand this half angle formula, because we can see this is half angle x, which means on my right hand side I do have 2x. Okay, that means this x means it's half of this. Okay, that's half. That means, let's see, sine square of x, of course, is 1 minus cosine of 2x over 2. Okay, and cosine square of x is the same, 1 plus cosine of 2x over 2. Okay, one more comment. Please note that for sine of x, sine square of x, and cosine square of x, we're using the same function, cosine. Okay, it's just plus or minus. Okay, now let's see. Sine square of 2x, that's what I was trying, yes, to explain. This means this is half angle. That means on the right-hand side, I have to double it, 4x. That means I follow the same formula, 1 minus cosine of 4x over 2. 2x, 4x. Okay, that's double. Okay, if this is 3x, this is 6x. 3x, 6x. 5x, 10x. 5x, 10x. 10x, 20x. 10x, 20x. Okay, that's when we understand how the formula works. Okay, another integrals that we already learned in Calculus 1 is the just direct antiderivatives or immediate integrals. Integral of sine of x dx, of course, is negative cosine of x plus the constant of integration, and integral of cosine of x dx is sine of x. Okay, that's me. Let's start. What we will do, we will have a few types. That means we have to focus on the type of integral, which it's represented by a product of sine function and cosine function, but they are taken to the power of n and m. And we can play with these numbers. That means, first of all, let's start with n and m being both an even number. That means, let's say sine square times cosine square times cosine square. Sine square maybe times cosine to the power of 4. That means n and m are both an even number. Then we will always use the half angle identity. Let's see. I do have just this one because I can consider that cosine of x is taken to the power of 0. That means it's gone. That means this is also this type, sine square of x. How can we square of x dx? We have to use half angle formula. I will replace sine square of x with 1 minus cosine of 2x over 2. Over 2 means 1/2. I can pull out 1/2 in front of the integral. And now, relatively easy. Integral of 1 dx is just x. Integral of cosine of 2x, it's sine of 2x over 2, or 1/2. Okay, I mean, I can, that's fine, over 2, because we have to divide by the coefficient of x. Okay, and that's it. We can see how nice and quick we can get. I did distribute half, and I get the common denominator. We don't have to. I mean, a little bit of algebra never hurts, but this is important. Okay, please remember, sine square of x dx, half angle formula. And respectively the same thing, integral of cosine square of x dx, the same thing. Please remember, half angle formula. Okay, I can write half angle. Okay, 1/2 in front of the integral. Integral of 1 dx is x. Integral of cosine of 2x is sine of 2x, and divide by 2 or multiply by 1/2. And I did the same thing. Okay. Oh, now we do have an integral of sine to the power of 4 x dx. That means this is still an even exponent. For the even exponents, we're supposed to use the half angle formula, but we only know the square. That's when we remember how can we rewrite. We can rewrite this way, sine square of x and again squared, which will give me 4. I will put the half angle formula, and I still have to remember about this. That means let's see. 1/2 in the denominator, squared will be 1/4. That means I'm taking 1/4 in front of the integral. And having 1 minus cosine of 2x squared, I did FOIL this, which this is 1 minus cosine of 2x. This is of course half angle. 1 minus cosine of 2x squared, 1 minus cosine of 2x times 1 minus cosine of 2x. And then you can see you will get this expression if you will FOIL. Okay, that's what I have. I have 1, no problem, I can integrate 1 dx. I can integrate cosine of 2x, no problem. Constant is also not a problem in front of the function. But what I do have another square, another cosine function taken to the power of even number. I will place the half angle formula again. The only thing is we have to note that this angle is half, which in my formula I will see 4x. That means I did copy 1, I still copy this function, and now cosine square of 2x, using the half angle formula, I have 1 plus cosine of 4x over 2. Okay, and let's see all my presentation. What I did, I still copy 1, I still copy this function, and this one I kind of split for 2. 1 over 2 is 1/2, and cosine of 4x times 1/2. Okay, I can do this way. And now I am integrating. Integral of 1 is x. Integral of cosine of 2x is sine of 2x over 2 times 2 will give me 1. That means I can possibly write that 2 and over 2. Just for you to see this. 1/2, integral of 1/2 is 1/2 x. Integral of cosine of 4x is sine of 4x over 4. Over 4 and times 2 will give me 1/8. Okay. I can write over, the 1/2 was here. And 2 times 4 is 8. Okay, 1x plus half x, 3/2 x. The 2 is gone, and 2 times 4 is 8. That's my final answer. Okay, but we can see we did use the half angle formula. Okay, now we do have a product of sine x, cosine x, and both of them are taken to the power of even number. Still half angle formula. For cosine of x and sine, is cosine square of x and sine square of x. Okay, I have to multiply them. That means 2 times 2 is 4. That's constant, 1/4 will be placed in front of the integral. And this one I have to FOIL. 1 minus cosine of 2x, 1 plus cosine of 2x. It's actually the conjugate expression. That we can square the first quantity minus square the second quantity. 1 and cosine square. You more than welcome to FOIL this step by step. You should get this expression. Okay, and we see square, again, half angle formula. That's when we did use half angle. Okay, and we will use again half angle. I copy one, and please note the same thing. This is half of the angle, which we have to place 4. Okay. Okay, what I did have 1 minus, and now 1 over 2 is 1/2. That means 1 minus 1/2 is just 1/2, and cosine 4x over 2, which will be cosine of x times 1/2, and this negative is affecting that plus. That means we do have subtraction. Okay, integral of 1/2 dx is 1/2 x. Integral of cosine of 4x is sine of 4x over 4. And we can multiply. Oh, actually, I did factor out 1/2. 1/2 and 1/2 in front of the integral will be 1/8, combining with this 1/4. And this will give me just x and just sine 4x over 4. Okay, that's me. Now we do have another type, another kind, still a product of sine of x and cosine of x taken to the power of n and m respectively. But now we do have different situation. One power is odd, one power is even. Doesn't really matter which one, but that's how it works. If we can probably have the difference in the process, but the concept is exactly the same. That means n could be even, or m could be even, or could be the other way, but they have to have different. They can't be both odd or both even. We know what to do if they are both even. Okay, one odd, one even. That means what we will do depends, okay, depends of which one. We will try to use the u substitution, and once we will let u to be sine of x, or we will let u to be cosine of x, okay? Depends on the situation, okay? We can see, like this one, the first situation is telling me that cosine of x has the odd power. Okay, the cosine of x has the odd power. This one is telling me this situation will be good if the sine of x is taken to the odd power. But I don't really want students to memorize this. We will kind of like think like along the process, along the integration. Let's see. Oh, actually, I don't know if we realize I did change the slide. This one is really similar situation if both of the powers are odd. Okay? That means if both of the powers are odd, okay, then we can pick the situation. We can do, if the cosine is odd or the sine is odd, we can convert, and we can use either way the u substitution. That means, let's see. Okay, I have sine square of x times cosine of x dx. Cosine of x is taken to the power of 1. That means this is odd. And actually, I don't really have much to do because I can use my u substitution right away. Okay, that means I can think, let me do this. I will keep this because this is my single cosine of x. That means if this is my cosine of x dx, this represents the derivative of sine. That means it's nice and ready to let u to be sine of x. That means u is sine of x, du is in my box, cosine of x dx. Derivative of sine of x is cosine of x dx. And then sine of x is squared, that means u squared, and this box was actually u. Integral of u squared du is just u cubed over 3 plus the constant of integration, and we can substitute back instead of u sine of x. Okay, we do have our u substitution. One more thing, sine square of x means exactly the same like this notation, sine of x squared. Okay, or the same for cube. Sine cubed of x means that the entire function sine of x is cubed. Okay, now let's look at this one. Sine square of x times cosine cube of x dx. That means now we do have one even, one odd. We have to attack the odd number. That means that's the odd number, 3. And I will split this as a power of 2 and 1. Or I could say the other way. 1, I have to pull out one single cosine and the remaining even. If this will be 5, will be 4 plus 1. If this will be 7, 6 plus 1, because I need that 1. Okay, that we can see this is that 1, cosine to the power of 1. And I will keep this, I will save this box to be du, which now this means, okay, this is cosine square, and cosine to the power of 1 will give me the original cosine cube. Okay, that's me now thinking a little bit, like few steps ahead. I will apply the u substitution, and I want this to be du, which means the rest of the integrand must be rewrite in terms of sine. Okay, the entire blue part must be in terms of sine, because I will let u to be sine of x. Of course, sine square of x is fine, and cosine square of x, we remember from the first slide, Pythagorean identity, is simply 1 minus sine square of x. And still keeping, not touching, cosine of x dx. This is my du. Okay, let u to be sine of x, du is cosine of x dx, and let's see. Sine square of x will be u squared, sine square is u squared. And this is my du. Perfect, we can see, that's the du. Let's distribute u squared times 1, u squared times u squared, u to the power of 4, and negative will stay. We can integrate u to the power of 2, the integral is u to the power of 3 over 3, minus u to the power of 4, and integral is u to the power of 5 over 5, plus the constant of integration. And now, instead of u, I will put the original x variable function sine of x. Sine cube of x over 3, sine to the power of 5, x over 5. Okay, let's look at this one. Okay, cosine cube of x, the same thing. We don't have a sine, but let's see. We have to apply the same process. That 3, I will split as a square plus 1. That means square plus 1. And we remember, I will hold this, the single cosine, as for my du. Now, the rest of the integrand must be rewrite in terms of sine. That means I will rewrite cosine square of x as a 1 minus sine square of x. That's the same. Still not touching cosine of x. And now I think we're ready for the u substitution. Let u to be sine of x. du is cosine of x. Perfect. Cosine of x dx, of course. That means this is 1 minus u squared. Integral of 1 du is u, integral of u squared, u cube over 3. And substituting back the sine of x function. Okay, that means that's everything. I mean, that's all of the types for sine and cosine. Now we will try to make a combination of tangent of x times secant of x. And we can probably guess it's similar situation. They are kind of like a derivative to each other. We have to be careful with the exponents, because we remember derivative of tangent of x is secant square of x. And derivative of secant of x is secant times tangent. That we have to like play with all of these exponents, pull out the functions, the same idea, the same concept like for sine and cosine. Okay, but I make the summary page. Having tangent of x times secant of x dx taken to the power of mn respectively, okay, we will have this, we have to take these steps in order to integrate. If both of the exponents are even, if both of them are even, we will use always this substitution. U, we can let U to be tangent of x. And everything will work because we need even exponent for the derivative, secant square of x dx, and we can play with the other function. The only thing that we will need the Pythagorean identity, but for secant and tangent. That means hopefully we remember that secant square of x is 1 plus tangent square of x. Okay, and let's see the other summary page. The same product, tangent times secant, and if both of the exponents are odd, we will let u to be secant of x. And then we will probably need this Pythagorean identity. Tangent square of x is secant square of x minus 1, to rewrite 1 in terms of the other one. But that's easy to remember. If both of them are odd, let u to be secant of x. If both of them are even, let u to be tangent of x. Okay. Okay. Okay, see tangent square of x times secant square of x dx. We can see nice and easy, because what we do have both even, we will let u to be tangent of x. That means this one is almost nothing to do, because I see the derivative of tangent right away. That means this will give me du, which is derivative of tangent, and now I knew that the entire integrand, the rest of them, must be rewrite in terms of tangent, and it is. That means I will let u to be tangent. Tangent of x du will be secant square of x dx. And let's see, tangent of x was u squared, and this is my du. Okay, done. Integral of u squared, everybody knows, u cubed over 3, and substituting back, tangent of x cubed over 3. Okay. Tangent to the power of 6x and secant to the power of 4. That we know that we will use the u substitution, u will be tangent of x. That means I will change this secant for 2 plus 2. Okay, we can see 2 and 2, the powers. And I will save this one for my du, because derivative of tangent is secant square of x. That means I'm not touching this box. But the rest of them, I mean the rest of the formula, the rest of the integrand, must be rewrite in terms of tangent, because I will let u to be tangent. That means tangent to the power of 6 can stay, no problem, but secant square to the power of x equals to tangent square of x plus 1. Okay? And now we're ready, because we do have this part in terms of tangent. Great, and this I'm saving for my du. U is tangent of x, du secant square of x dx. U to the power of 6, u to the power of 2 plus 1, and this is my du. Let's distribute u to the power of 6 times u to the power of 2. We're adding exponents, u to the power of 8, u to the power of 6 times 1, of course, u to the power of 6. An integral of u to the power of 8 is this, u to the power of 6 is this, plus the constant of integration, and we can substitute back, instead of u, tangent of x. Okay, let's look at this one. Tangent to the power of 5, x secant to the power of 3, x dx. That means now we do have both odd. And we remember, having 2 odd, we will use the u substitution, but we will let u to be secant of x. Derivative of secant of x is secant times tangent. That means what I will do, I will pull out one tangent, which this will give me exponents 4 and 1, and I will pull out one of the secant, which this will give me the exponent 2. That we can see we have secant square times secant, tangent to the power of 4 times 1. And what I will do, the single one that I pull out from each of them, secant and tangent, I will keep and I will save to be du. Now, the rest of the integrand must be rewritten in terms of secant. Okay, because I want u to be secant of x. That means everything must be in terms of secant. That means what we have. We do have secant squared, that's fine. This is still my du. Okay, secant square of x stays, secant square of x. Now, tangent square, and another square. That means tangent square of x is equal to this. Secant square of x minus 1, and another square will give me 4. Okay, now we're ready because the entire, except the green box, the entire blue part, I would like to nicely underline, is in terms of secant. I can let u to be secant of x. Du is in my box, secant of x, tangent of x dx. Perfect. This is my du, and secant square is u squared minus 1 and times another secant square, which is u squared. I did expand this, foiling u squared minus 1 times u squared minus 1. We will get this, and we still have to distribute. U to the power of 4 times u to the power of 2 is u to the power of 6. U to the power of, let me show you. Of course, we know what we're doing. We have to multiply this. Okay, and then we integrating. U to the power of 6 du integral is u to the power of 7 over 7, u to the power of 5 over 5, copying a constant 2, u to the power of 3 over 3. And then substituting in terms of u, secant of x. Nice. Okay, and I still have few integrals. Let's see, that's nice multiple choice question. Evaluate an integral tangent of x times secant cube of x. That means this one is definitely both of the exponents are odd. I will use the u substitution secant of x. But I have to get ready. I will pull out one secant and the remaining square. That means we will have not sine secant. Secant square of x, and then secant times tangent, I will keep them as a derivative, du. And actually, perfect. This is derivative of secant of x, and my rest of the formula is in terms of the secant. That means, let's see, u will be secant of x, du is derivative of secant times tangent. Excellent. Now I do have secant square, which will be u squared, and simply du. Because that's what the u substitution is showing me. U to the power of 3 over 3 plus the constant of integration, secant cube of x over 3 plus the constant of integration. Really nice. And I have another one. Oh, exact values. We will probably need a little bit of unit circle. Okay, what we have? Secant to the power of 4 theta tangent cube theta, d theta. Oh, actually, this one is theoretically the type that I didn't cover, but I hope we understand the concept and we can still figure out. That means now, if one exponent is odd, one even, we have to think what will work. That means if I will save at the end secant square of x, then everything must be in terms of tangent. And I think this will work. If this will not work, then you have to use another method, which I believe the other method will also work. Okay, let's use the first one. I will split this for secant square of x, tan cube of x, and I will put another secant square of x. Yes, we can see 2, 2. And I want the last part to be du. This secant square of x is the derivative of tangent. This means that the entire integrand must be rewrite in terms of tangent. Secant square is 1 plus tangent square of x. Oh, actually I use x. It's okay, I can use since theta is x. Oh, I don't wanna mess up my, okay. And this is secant square of x dx. Now I did forgot something because I'm trying to, this is still tangent. Tangent cube of x. And now I can copy secant square of x dx. Excellent, that's my du. Okay, my entire integrand is in terms of tangent. I will let u to be tangent of x, du is in my box, secant square of x dx. Okay, 1 plus u squared, u cubed, and this is du. Let's distribute. 1 times u cubed is u cubed and u squared is u to the power of 5. Okay, u to the power of 4 over 4, u to the power of 6 over 6. And actually we need a new limits of integration. That means, let's see, the limits of integration, new limits. If x is 0, we can see 0, then u is tangent at 0, because u was tangent. And tangent at 0, of course, is 0. That's we do have 0. Oh, actually, that was also 0. Okay. Now, if x is pi over 4, u will be the new limit, will be tangent at pi over 4. And tangent at 45 is 1, from 0 to 1. The best limits of integration. Substituting 1, I have 1/4 plus 1/6. Substituting 0 is just 0. Okay, that means this one is 6 plus 4 over 24. Oh, actually 12 is also the good the lowest common denominator. I didn't really use the lowest common denominator, but I can simplify, no problem. 5 over 12. Excellent. And as we can see, it's a little bit longer. And don't worry, what you can do, you can also try to use the secant of x as a u. You can try to do, but you will get the same thing. And I have one more. Okay, it's another definite integral, sine square of x, sine square of theta times cosine cube of theta. That's me. Hopefully we remember, because that was the beginning of the session. Sine square cosine cube. One even, one odd. That means what we do, we attack the odd number and we will put square and 1. I will keep 3, okay, outside, or maybe not. Let me keep 3 sine square theta, cosine square theta, and cosine theta. 1 and 2. And I'm keeping this to be du. Cosine is derivative of sine. Now the entire integrand, without the box, the green box, must be rewritten in terms of sine. 3 sine square theta will stay, and cosine square is 1 minus sine square theta. And I can copy cosine theta, d theta. That's my potential d. Okay, let's do the u substitution. We do have everything in terms of sine. That means u, I will let u to be sine theta. du is derivative of sine, cosine theta, d theta. Okay, sine theta is u squared, minus another 1 minus u squared. And cosine theta d theta is simply du. Let's distribute 3u squared times 1, 3u squared times another u squared, 3u to the power of 4. Integral of 3u squared is simply u cubed, nice. And 3u to the power of 4 will be 3u to the power of 5 over 5. And this is definite integral. We need a new limit of integration. New limits. Please remember, do not use the original limit. X is 0, then theta will be sine of 0. Not theta, u. Sine of 0 is 0. Okay, 0, the lower limit is 0. We like 0. And now, if x is pi over 2, then u is sine of pi over 2. Again, one really nice limit of integration. Okay, we do have new limits of integration. Then let's integrate. Substituting 1 cube is 1, minus 3 over 5, and 0 will give me 0. 2/5. Really nice. Okay, please check all of these integrals. Make sure that you understand the concept of integrating them. It's almost the same concept for each of them, and just make sure that we know what is integral and what is derivative. Thank you.